the graphs or the equations of rational functions where it's fraction equal to a fraction. What we're going to do to solve those is we're going to solve them by cross multiplying. And you probably did this in middle school, but you may not have done it with as complicated of problems. So it might be kind of simple problems that you use when you solve proportions, and that's kind of what this is on 1 through 4. But if you look at 5 through 8, it's not like that because it's not fraction equal to a fraction. What you have to do on 5 through 8 is like you have to make it a fraction. So you're going to add or subtract and then do the cross multiplying thing. Okay? So on number 1, whenever you do cross multiplying, I usually do the part with the x first. Now, because there's 2 parts with the x, you do have to distribute, so 5 times the x and 5 times the 5. So you'll have 5x minus 25. And then you also do 4 times 5. After you do that, you just solve it, so add 25 on both sides. And then divide by 5. Now, on some problems, whenever you're solving, you have to check your answers. That happens whenever you have x's on the bottom. We don't have any x's on the bottom here, so my answer is good. The only time I have to check it is whenever there's not an x on the bottom, or when there is. So we don't even have to check number 2. Number 3 and number 4 are the ones we're going to have to check. Try number 2, see if you can do it. Just be sure to distribute everything. Alright, so I'm going to do 15 times both things, so 15x minus whatever 15 times 6 is, which is 90. And then I'm going to multiply this way, make sure that 3 multiplies by both things, so negative 6x minus 6. I want to combine my 6x over on this side, so I think it's 21x. I want to add 90 on that side, I think it's 84. And then when you divide by x, you do get 4. Alright, let's look at number 3. So, on number 3, I want to do the same thing, but it's not equal to a fraction. But because 4 is just a number, I can put it 4 over 1. And then I want to solve it. Now, before I solve it, I want to think about it just a second, because the ones I have to check are ones where if there's something on the bottom, you don't want it to equal whatever x can't be. Think about the domain of rational functions. Think about where there might be vertical asymptotes or holes. Look at the bottom of these 2 fractions. What can x not be? 1. Because x minus 1 can't equal 0, so x can't equal 1. So what that means is we're going to work out the problem, and if we get 1, that means our answer is no solution. If we don't get 1, we're good. So that's how we're going to check it. We don't actually have to go back and check it, but we just have to make sure that we don't get that. And that might happen. It's possible that you could get an extra answer or something like that. But that's what I can't get. Okay? So I'm going to multiply. I'm going to get 5x equals 4 times each thing. So 4x minus 4. Subtract 4x. So that's just a 1x equals negative 4. I'm good. I didn't get a 1. And we're okay. Alright, let's look at number 4. So start off the problem by thinking about what x can't be. So what can x not be here? Negative 1 and negative 7. So if I get a negative 1 or a negative 7, I just cross it off because I know it can't be those 2. And then I just work it out like normal. Now, when you work this one out, I'm going to do one part for you. If I do this one right here times this one, I do have to use FOIL because x has to multiply by both things and 1 has to multiply by both things. So basically I'm distributing everything. So x times x would be x squared. X times 2 is 2x. 1 times x is x. 1 times 2 is 2. And then I'm going to let you work out that side and continue. Okay, so when I multiply the other side, we'll have x times x, which is x squared. X times 7 is 7x. 3 times x is 3x. 3 times 7 is 21. Alright. Let's add this together, combine a little bit. Let's make that 3x. You don't have to do that. That's just what I think is easier. I would start with the x squareds. If you subtract x squared on both sides, the x squareds do go away. I'm just going to cross them out because I know they go away when you subtract them. And then I'm going to get my x's together. So I'm probably going to subtract 3x over here to make that x's still be positive. And then I'm going to subtract 21 on both sides. Divide by 7. You do get a decimal or a fraction. You can leave it as negative 19 over 7 or negative 2.71. I'm just going to leave it as the fraction, but your decimal is okay. So when you're working out these problems, you can have decimals, you can have fractions. I know you don't like them, but as long as it's not equal to whatever we started with, then you're good. Okay? Alright, let's look at these at the bottom. So to solve these, it is a little more complicated because we don't have fractions equal to fractions. And so what we want to do is we want to make whatever side is not a fraction, we want to make it a fraction first. So we want to add them. The way that we have been doing adding and subtracting and get a common denominator, that's what we want to do. So this 5 over x and the 1/3 here, I want to go ahead and get a common denominator. What would be the common denominator? 3x. So that means I'm going to multiply this one by 3, this one by x. And so I'm going to start it over here, so that's going to give me 15 plus x over 3x equals 1. Now I don't have a fraction on the right side, but it's a number, it's a 1, so I can make it 1 over 1. So it's just the fact of getting that common denominator, making it a fraction, and then now you're at a problem just like we just did with proportions. What can x not be in this problem? It's actually a 0 what it can't be, because the only thing on the bottom is a 3x or an x, and so in this problem x just can't be 0. Okay. Alright, let's go ahead and solve it. So we're going to cross multiply. 1 times 15 plus x, and then 1 times 3x. Get our x's together, so subtract x on both sides. Divide by 2. And we get x is 15 over 2. And that's okay. We didn't get 0, so we're good. So we've got 15x that we want to get. So over here we want to multiply by 5x. Over here we want to multiply by 3. So times 3 times 5x. So that means that we've got a 15x on the bottom. On top we've got 6 plus 5x equals 4 over 15x. Alright. Several ways that you can solve it from there, but you guys are probably just cross multiplying, so let's do that. 15x times 4 is 60x. Okay, 15x times both of those. So 15 times 6 is at 90. And then 5x times 15x is 75x squared. Did I do that right? Alright. This one's different because I have my x squared here. And when you solve it, and if there's an x squared and the x squared doesn't go away, you have to like factor or something like that to solve it. Okay? So what I'm going to do is I'm going to move this 60x over. I'm going to get 0 equals 30x plus 75x squared. Alright, and what I'm going to do is I'm going to try to factor that. If it's 3 terms, that's where you look for, you know, something to multiply to give you the last term and everything. But here's just 2 terms, so this is a greatest common factor problem. And our greatest common factor is 15. I think 15 goes into it, and then also an x. you're left with 2 plus 5x. After you factor it, then you set each part equal to 0 to solve. So you get 15x equals 0, 2 plus 5x equals 0. This gives me x equals 0. This gives me x equals negative 2/5. Now, I didn't at the beginning of the problem talk about what x can't be, but I should have done that. So at the beginning of the problem, look at what's on the bottom. What can x not be? X can't be 0. Well, we got 0 for one of our answers. That means that's not an answer, only that one. It is possible that both answers you get could work. So don't be surprised that you could have more than one answer. But always check and see what x can't be whenever we try to decide what it can or can't be. Alright, on 7. Let's start like we should by thinking about what x can't be. So in this problem, x can't be 0. What else can't it be? Negative 2. You look at every bottom of any part of the fraction in the problem. So x can't be 0 or negative 2. Alright, what part of the fraction do we work out first? The left-hand side, because that's the side that's not a fraction yet. Think of the 3 like 3 over 1, and we need to get common denominators. So our common denominator here would be x. That already has it, so I don't do anything with that one. I just need to multiply this one by x. So that's going to give me, let's see, I think I'm going to write it here. 1 minus 3x over x equals 4x over x plus 2. Alright, I'm going to cross multiply. So x times 4x is 4x squared. I'm going to multiply here. Notice it's binomials, so I'm going to have to do a little bit of everything. 1 times x is x. 1 times 2 is 2. Negative 3x times x is negative 3x squared. Negative 3x times 2 is negative 6x. I'm going to combine like terms there on the right. So I've got a negative 3x squared. The 4 and the negative 6 is negative 5x. And then a 2. Because I still have some x squareds and the x squareds don't go away, I want to put everything on one side and make it equal to 0. And actually, I want whatever's with x squared to be positive, because if it can be factored, it's easier to factor that way. So I'm going to move all of this over here with the 4, and I'm going to make it 7x squared, and then I'm going to change all of these signs. The reason I did that is to make the number with the x squared be positive, because it's easier to solve it that way. Alright? Because the x squared is still there, I have to factor. Because there's 3 terms, this is where you factor, like, you find the things that multiply to give you 7 times 2, 14, and add to give you 5, or subtract to give you 5. So what numbers multiply to give you 14 that give you 5 when you subtract it? 7 and 2. So I'm going to factor that. I'm going to come over here to the side, 7x squared. I need that to be a positive 7 and a negative 2 to make it work out. And then minus 2x plus 7x minus 2. Alright, common factors here. There's just an x in common, just a 1 in common there. Divide it out, you get 7x minus 2 on both of them. So when I factor that, I get 7x minus 2 and then x plus 1. We're running out of room, but we'll keep on. Once you get the factors, you just set each one equal to 0 and solve. In this one right here, you get 2/7. And then this one you get negative 1. And this problem is a problem where we ended up with two answers, which is okay. Neither of those answers is what x can't be, and so both of them are correct. Any questions? Alrighty. Let's go ahead and look at number 8. We're going to work out the left side first. Let's just think about it real quick, though, before we work it out. What can x not be? 1 and negative 1. So we want to get a common denominator. In this case, it's going to be x minus 1, x plus 1. And so I need to multiply this one by x plus 1. And this one by x minus 1. So we would have 3x plus 3 plus 1x minus 1 over x plus 1x minus 1. Go ahead and simplify the top, so that's 4x plus 2. Now, most of the time I've told you when things are factored like x plus 1, x minus 1, not to multiply it out. But when I solve this, I'm going to have to do 10 times that. And because it's multiplied like that, when I multiply that 10, that's going to be really strange. So I do want to go ahead and multiply here because I'm solving an equation. Okay? So I'm going to do x times x, which is x squared. The negative 1 and the positive 1 is going to go away. And then you get minus 1. Basically, I'm doing x times x times 1, so negative 1x. 1 times x, positive 1x. 1 times negative 1, which is negative 1. So that positive and negative 1x went away, so that's why we get that. Now, I could cross multiply to solve it, and you are welcome to do that. I want to show you real quick, there's one other way. If the bottoms are equal, the only way that these two fractions can be equal is if the top is equal. So as long as you have the same thing on the bottom, you can just set the top equal to 0 and not have to cross multiply. Because cross multiplying can be really strange, especially with all the things to multiply. So that right there tells me that 4x plus 2 equals 10. Subtract 2 on both sides. Divide by 4. And we get 2. You could cross multiply and then work it out, and that will be okay. However, if the bottoms are already the same, then it's easy just to solve it like that. And just to let the tops equal each other. Alright. I want to show you one other kind of problem. It's basically a problem very similar to what we've just been doing, except they wrote the problem in words. And I know that scares you a little bit, but I promise you that these words, it's easier to figure out, and I'll show you how to do that. Okay? So in 9 through 12, we're talking about people doing some kind of job, and they do it alone and then together, and we talk about if they did it together, how long would it take them, or if they did it separately, how long it would take them. So in number 9, we have Rob and May. Maybe that's how you say it, I'm not sure. It takes Rob 10 minutes to sweep a porch. It takes May 11 minutes. And we want to know how long it would take them if they did it together. Now, whenever you're doing the problem, you're going to make fractions out of the time and the work. If it told you that it took Rob 10 minutes to sweep 5 porches, then how many ever jobs there are goes on top. And then the time goes on the bottom. So it's like jobs over time. In most of these situations, it's only one job. It's only sweeping one porch. And so it's going to be 1 over something. Okay? And you're just going to kind of add it together and equal it to whatever together would be. So in this case, it's going to be 1 over 10 for Rob. May is going to be 1 over 11. And we're going to equal it to 1 over x because we're looking for how long it takes them to do it together. Again, the ones are because it's only one job that you're looking at. If it was several jobs, then you would put how many ever jobs it would be that went on top. Now, after setting it up that way, it's just a problem like we were doing on the other side where we get a common denominator, we add it, and then work it out. Now, because this is 1/10 and 1/11, if you want to just add it 1/10 and 1/11 on your calculator and not get a common denominator, that's fine, because those are just numbers and not x's. That's up to you if you want to do that process. I know that the common denominator is going to be whatever 10 times 11 is, 110, and then work it out. If you add that, you do get 21 over 110. So either just add those together on the calculator or get a common denominator and work it out. From there, cross multiply and solve. So 21x equals 110. And then to solve, you're just going to divide 110 by 21. And you're going to get decimals a lot of times. 5.238 minutes. And that makes sense, because if it takes one of them 10 minutes and the other 11, if they do it together, it should take them a lot less time. Alright, because the 40 bushels was the same for every person, you can just consider it to be one job. So we'll have 1 over 11 plus 1 over 12 equals 1 over x, because that's what we're looking for. And again, because those are just fractions, 1 over 11 plus 1 over 12, you can just add them, get a common denominator on the calculator if you want to. From there, cross multiply, so you'll get 23x equals 132. Divide 132 divided by 23, and you get that 5.739. One other kind of problem I want to do with you. It's very similar, but the difference is on this one that it's looking for how long it would take somebody to do it alone instead of together. So here it tells me what it is together. Together is 6.24 hours. Lisa would be 13, and what we're trying to find out is about Ryan. Okay, we do it the same way, except when we put the together, we're going to have numbers for that. Okay, so we'll have 1 over 13 for Lisa. We'll have 1 over x for Ryan because we don't know how much it is for him by himself. And that's going to equal 1 over however long it took them to do it together. In this case, you do need to get a common denominator. You can't just add the 1 over 13 and the 1 over x because there's an x there. So I multiply this by x. Multiply this by 13. We'll get x plus 13 over 13x. That equals 1 over 6.24. And it's going to be weird decimals, but it's okay. 6.24 times both of those, so that's 6.24x plus 13 times 6.24. And that equals 13x. I would take 13 and subtract off that 6.24 to get it together on one side. So 81.12 equals 6.76x. Divide 81.12 divided by 6.76. And it came out to a nice answer with all kinds of decimals throughout the problem, but it came out to be 12.
Should it not be 40 on top?